Yes, Silky. It's good.
Bonsoir too. I'm afraid that my French is not really that good, and I'm really very happy to be able to share information with you with the BordeauxJUG. And thanks to Lillian and Matthew for inviting me and setting this up. And thanks to again to the Clips in Jakarta EE for allowing us this space. And hopefully for the next hour or so, I'm going to showcase a few things about the Java module system and a brand new library, a brand new project, which is called Layrry, that brings a lot of features. Features that allows you to create modular applications in a much easier way. Please feel free to stop me at any time whenever you have any questions. If you want to ask them directly or on the chat, I'll be very happy to answer immediately. Otherwise, we can always have questions at the end. Okay, without any further ado, I'm going to share the screen and start the slides. All right, we should see the terminal. All right, and the slides coming up in just a moment. Oh, that was not the window that I wanted. That is the button that I wanted. Okay, finally, slides. All right, building applications with JPMs and Layrry. So my name is Almiray, and I'm currently employed by Oracle. I do a lot of work on the open source, and I'm also a member of the Apache Group PMC, and I created an event or a community called Hacker Garden. You might have heard of something similar to Hacker Garden called Have Commit Push, which is a physical and online event that we hosted in Paris this year and last year, which is basically a way for you to find other members, other peers that would like to work on open source projects and make the world a better place by making one commit at a time. Anyway, so the point is that I love talking about open source, and that's how I discovered the tool that I'm going to talk today. Now, you may be aware that JPMS stands for the Java Platform Module System, which was also known as Project Jigsaw many years ago. Now, this particular project was in development for a long time until it was finally released in version 9 of Java. That was close to 4 years ago. And the idea for Project Jigsaw was to break down the JVM monolith. The JVM itself is comprised with lots and lots of code. It's a huge code base. And then trying to make changes that if you pop something in one place, then something else will happen in another one. So the architects decided to try to make sense out of that chaos. And that's how the JPMs came to be. And because the way that this happened, the way that they unraveled the different modules, they said, well, they thought that it may be a good idea to offer these capabilities to user space, to our space, to the developer space. And so the promise is that with this foundation of modules and we have better encapsulation, we can design our applications in such a way that we can define what pieces of code are actually private, what pieces of code can be shared to the outside world under certain circumstances, and what pieces of code are freely available for everybody to use. So when this was in development, some people thought, well, this is a great idea, let's see how this works, and some of us were not very happy, and some of us were skeptic of how JPMS will turn out to be. And you might have seen some people, you might even be one of those people that when asked about what JPMS is or what can it do for you, then they come with these particular answers. So for example, so JPMS only allows one version of a module. As a matter of fact, JPMS says there are no versions for a module. As a matter of fact, if you use a number as the last character or the last set of characters in a module name, when compiling the module descriptor, it will cast a warning because you're not supposed to do something like that, even though you might not intend to have a version number. So because of this, some people believe that JPMS is not really usable because the problem is, what if you have conflicting versions of a dependency? You have version 1 and version 2 that are binary incompatible, then you cannot build an application that can have those two capabilities. Another thing is that JPMs doesn't allow adding modules at runtime. So you compose your application during design time. You define, I want to grab this module and that one, another one. And you compile your application, you package, you maybe create a JLink image, off you go. And then you say, oh, I need another module. What can I do? Well, you have to go back to development time and add the module. Well, so that is not a really nice experience. Another thing that is true is you have to modularize all dependencies in order to reap the benefits of JPMs. And for modularizing your dependencies, there are at least 3 levels. There is the full modules that you have to define and you write the module descriptor. There is the automatic module name, where you simply claim the name of a module, but everything in the module is available, is open. Or you simply say, I don't care about the module name, and I will let the JVM pick up the name, which is usually mapped to the file name of the dependency, the jar file. It's also hard to map dependency coordinates to a module dependencies. The reason being, again, is that the specification doesn't say how a module should be packaged. Right now, it's a coincidence, it's more like a convention, but it's not exactly, again, it's part of the specification, that we have one module definition per jar. In the future, this could be different. We don't know. And because that's one of the reasons why the spec is still open, maybe there in the future, there is some other mechanism that will allow us to map a dependency coordinate, jar files, so Maven coordinates, to module names. And if you do not export packages on a module, then you may not be able to see it. And another thing that can happen is that split packages, say, for example, you have something like Acme utilities in a jar, in a module. And then this same package is found in another jar. Now that is allowed when you're running the class path. But when you're running in the module path, that is no longer allowed. So you have to redesign your code. So for these reasons, some people think, yeah, JPMS sounds cool, but no, thank you. That's a lot of hassle. Also, some of the features that I just described can be provided by other alternatives, like the very well-known OSGI. OSGI provides many more features on top of the things that I just described, but this talk is not about OSGI. This talk is about the Java Platform Module System. Now, there is a feature in the platform, in the module system called layers. And this particular feature can help fix some of the problems we just described. Now, if you were to look into the Java doc of the JDK since version 9, you can find this class called a module layer. And you can think of a module layer as some sort of an organizer of the different modules that belong to that layer. And you can create a class loader that is attached to that layer. You can have hierarchies of layers in the same way that you can have hierarchies of class loaders. Now, and it's thanks to this module layer that the new API that is now being worked on as an open source project came to be, and that is known as Layrry. So let me show you quickly what the layer API is. This is what you find in the JDK. So basically what you have to do is create a base layer, a boot layer, and then assign a class loader. We will going to use the system class loader. And then you require access to paths. So you need access to the file system. So we're going to define 2 paths for 2 different jars. We assume that each one of these jars define 1 module, so that's good. Then we create additional configuration to find these modules. And then we see in line 12, the names of the modules that we expect. And finally, in line 14 is where we create the module layer based on all those definitions. And it's from that module layer, the full layer, that we can start loading classes, we can launch an application, we can work with it. Now, the API is direct, it's straightforward, but it's not very friendly. Also, if you have conflicting modules, well, you definitely have to add more code. So say, for example, you have an application that looks like this. Top level application, the module is app, depends on 2 other modules, foo and bar. Each one of them depend on a common module, which is the log4j API. But module foo depends on version 1 of the greeter module, and module bar depends on version 2 of the greeter module. So we have conflicting versions of the same module here. There are different artifacts. What can we do? And this is where Layrry comes in. The project is found in this particular URL. It's hosted on GitHub, like many other projects are. And Layrry is a brainchild of a fellow Java champion, Gunnar Morling. He works as an engineer at Red Hat. He also loves open source. He is the current lead of the Division project. He is the spec lead of Validation 2, and he blogs regularly at morling.dev if you're interested to hear more of his thoughts about open source and Kafka, Hibernate, and a few other things. So, recall what we saw a few slides ago on the module layer API. Here is how Layrry can simplify the API and allow us to have conflicting module versions. So Layrry defines a fluent interface design for the configuring layers. So we start with one layer called log, the name could be anything, and then we define Maven coordinates to find the jar files. And then we have layer foo, which depends on log. That's, you remember the diagram, it has this basic dependency, and also depends on version 1 of greeter. We have layer bar that also depends on log and depends on greeter version number 2. And then we have the app layer that depends on both foo and bar, plus its own module. And then we build the layer. And once we have this layers object, we can launch the main point or the main application that is found in the layers. In this case, it's an app class that may take additional arguments. And it's as easy as this. This application right now is able to handle conflicting versions of the same module name. Now, JPM Layrry is just the typical tip of the iceberg of what you can do with the Java Platform Module System. It is just a tiny abstraction on top of the vast majority of APIs that the JPMs gives you access to. Okay, so one thing is to say, this is how I can configure my application. This is the layers configuration. Great. How do I run the application? Well, there are several ways. You can create a main class that uses the Layrry API that configures the modules and then starts layers using layers.run. But because this is a common, Layrry already provides a base launcher class for you that performs all the configuration if you supply an external file. Now, there are different formats for externalizing configuration. And perhaps one of the most used today is YAML. What we're seeing in this particular window is exactly the same application that we saw before, with the same configuration, the same module definitions, the same conflicting modules, greeter 1 and greeter 2. The only thing that I'm missing here is the argument, the additional argument passed to the app class, but everything else is exactly the same. Now, you may be happy using YAML, or you may be like Bruno, which he doesn't like YAML. He hates YAML with a passion. He prefers other source files, other external properties files. So what about TOML? TOML is another external source file that is supported by Layrry. So you can either use YAML or TOML, and this is exactly the same example as we saw before, just using a different external configuration file. It depends on your taste which ones you want to get. Or if you don't like any of this, then the Layrry configuration is extensible. If you want to use XML, sure, why not? Just need to provide a configuration parser that understands XML. Or perhaps it's a different format. Or maybe you want to load it from a different resource, a database, or I don't know, whatever makes sense for your application. Layrry is able to hook it up, and that's it. So when I saw Layrry, I saw that we can have this ability of conflicting modules in a working application, but there was another feature that drew me to it, and that is being able to write plugin architectures. In a way, we have been used to our IDEs that can load plugins on the go and add behavior while the application is running. Most of the times we don't have to restart, but if we do, well, okay, you still can hook up additional behavior. But the original idea of OSGI and other plugin architectures is that you install a plugin that is specific to the application or the platform, and you get additional behavior. And if you uninstall the plugin, then that behavior gets removed. Well, Layrry allows you to do something like that. And this is how. So Layrry has one interface that defines two methods. And that's the only thing that we need right now. When Layrry detects that a new plugin, and we will see what a plugin can be, then the plugin added method will be triggered passing a plugin descriptor. And if a plugin gets removed, then it's no longer available to your application, then the second method is going to be invoked. Now, this is the class provided by Layrry. You have to provide an implementation of this interface. Here is a typical implementation of said interface. You will normally make use of standard Java facilities such as the server loader. Say that you have a class called MyService, which is application specific to you, and that the implementation of the interface, the plugin lifecycle listener that we're looking right here is also your application class. Then we make use of the service loader, and for each service that has been found in the specific model layer, because you could have many layers with many different plugins as complex your application may be. So it's a good idea to check that the services that you're loading belong to the layer that you are interested in. So that's where we are loading the service loader in this particular way. And the other thing that we do is check that it actually belongs to that layer in line number 9, because if you have a hierarchy of module layers, the service might come from a different layer. So anyway, it's always a good idea to check that what you're loading is coming from the right place. And I'm going to show an example of this in just a moment, how we actually make use of these classes. But before I do, there is one more thing that I would like to showcase, which is parameterization. Because even though you can create undefined applications using the Layrry API directly, and you can create applications using external files, there is already a little bit of repetition or duplication with the dependencies. Say, if you use Maven or Gradle, you will have the group ID, artifact ID, and version number of the jar file. In your module descriptor, you have the name of the module that may or may not match the name of the artifact. And finally, either in the Layrry API or in the external file, you also have to duplicate the Maven coordinates to locate the jar files. So is there a way that we can keep things in sync? Right now, there is no specific build tool plugin for Layrry. So there is no Gradle plugin. There is no Maven plugin yet. We will see if it's needed in the future. What we can offer you right now is a way to parameterize your external configuration files. So here we have an example of a JavaFX application. And you can see that the version numbers have been substituted now with value placeholders. This is using the template format for Mustache. As a matter of fact, you can use any template placeholders anywhere in the external file. If it makes sense to you to substitute the group ID for any of these artifacts, Yes, sure, why not? Or maybe it's the name. But the point is that JavaFX in this particular case requires platform-specific artifacts in order to run. If I were to define a specific artifacts in my external file, I will only be able to run it in that platform. But because I have this parameterization, and Layrry is aware of the different OS classifiers, then I can create a file like this and make it run in any platform where JavaFX is supported. The other thing is providing the version numbers of the artifacts that I want to use. And for that, we can use a secondary file. It could be any name you want to. It has to be just a properties file. And in this properties file, you can supply any key values. In this case, I'm just using the version numbers of the artifacts that I want to use. And you can see that the keys match the placeholders in the TOMO file. Once we have these two source files, and all our artifacts have been pushed to a Maven-compatible repository, it could be Maven local, or it could be a remote repository, then I can launch the application in this way. The Layrry launcher is a shaded jar that contains all the dependencies for you, and it knows how to deal with external dependencies. This is one way. Another way that you can do it is build your own custom launcher using the Layrry APIs. For if you need to create or bootstrap some resources before the application is actually started, then the launcher will be the right place to do it. Or there is another option for now, which is called JBank. JBank is a project that started almost at the same time. No, actually, I think it started in December or November last year, and later was started in March of this year. And basically what JBank does is take a feature, or started as a feature from JDK 10 called JEP 330, launch from source file. So with this feature, you can have a single source file and pass it directly to the Java interpreter, which will automatically compile it for you and launch the class. Now, this is great, but it's missing something that we as Java developers are very used to, which is jar files and modules and dependencies. Because launch for source file cannot work with external dependencies. But JBank gives you that capability. As time passed by, JBank grew out of JEP 330 and now provides additional features. You can even use JBank with Java 8 if needed be. But of course, in the case of Layrry, for modules, you require something that supports the JPMs. And the minimal version that we currently support is Java 11. Anyway, JBank has many ways for you to bootstrap a Java script or a Java class or a Java source file. One of the options is through something called add catalog, which is a naming convention for a Git repository on GitHub. In this case, we have a JBank catalog repository in the Moditech organization. And Layrry is one of those scripts that can react to JBank being invoked. And this, as a matter of fact, what happens under the covers, this will launch the Layrry launcher locally for you. If it's not available, it will download it for you automatically and then invoke your application passing those external configuration files. But I guess now is the time to show some actual code and see how these things can work. So I'm going to switch from the slides into the terminal. So I got the Layrry sources in this terminal, and I get examples on this other terminal. And the example for these modules is called Modular Tiles, and it looks like this. It is comprised of, it's either a Maven build, you can see the POM XML, or is a Gradle build, you can see the build.gradle file. Now, what is this application going to do? This application has a few modules that define the actual behavior of your application. It has the application is right here. This is the main class Let's see it right there. Make it a bit bigger. It's a standard JavaFX application, but it could be non-JavaFX. It could be any Java as long as it's modular. So what this does is just create a simple window and is going to expect some dynamic plugins. And the plugins are coming from other projects. Yes?
Sorry, I don't know your screen.
You're not looking on the screen?
Yes.
Oh.
It's okay. Thanks.
Oh, so there's some sort of delay now. I see.
Yes.
Okay, so I have to be aware of that. All right. So we have the main class here. And it's a very simple JavaFX application. It's not very complex. And it has some modules here that define plugins. Before I actually showed you the code, I'm going to demonstrate the application. And hopefully we don't have too much of delay. So I switch to the terminal, black, and I'm going to be sure that all the artifacts that Layrry needs to resolve are available in my Maven local repository. So I'm going to build my project. Well, actually, I just call it install, like this. And there I'm invoking Maven. And what it does is that it creates a directory called staging, where I can see a TOML source file that contains the definition of the layers and a set of jars that are the plugins, and this directory, which is currently empty, called plugins. Let's inspect the content of the layers file. It should be very similar to what we saw before. It contains the JavaFX. The different versions are going to come from the dependencies, from the version properties. But this is the special bit, the layers or the plugins layer. I mean, this is a name that is could be any name you want to. And this is the name of that directory that needs to exist in your local file system. And this path is relative to the external configuration file. That's why we saw that staging looked like this. So the plugins directory, which is empty, is next to layer stuff.
Sorry, problem to refresh screen.
Okay, I see. If I move quickly, is it now in black?
Yes, au top only.
Ah, like this. They should see a tree now. I hope.
No.
Okay, let's see. Let's change something. I'm going to stop sharing that. Oh, you can see it now.
Yes, it's good.
Okay, so we get about half a minute of delay. That's good to know. All right, so I'm going to launch the application. And I'm going to use JBank in a local way to launch it. And I can do that with JBank, Layrry, and then I say layers config, the layers TOML file, and then I say properties, and the version properties file. I'm going to launch it in the background, like this. And the window appears now. I'm going to resize the terminal so that we can see the changes live. Okay, so I'm going to wait until you can see that this is an empty window on top of the terminal.
It is okay.
There is no content there.
Yes.
Perfect. Right. So what's going to happen now? I'm going to copy from staging plugins prepare all the plugins into the staging plugins, which is a directory that is being watched by Layrry. The moment that I click enter, the application will change automatically. And you can tell that this is actually live by the time in the clock. Is today's date and it's about today, so right now, the same time. And there are two other tiles that just provide random values. Now, these three elements are the plugins. Now, watch what happens when I delete one of those plugins. Staging, plugins. Let's delete the one in the middle. Like this, we're just going to delete a file. Whoop, that's not what I want to do. That's PRM. Okay. And it's gone. So now we only have two plugins available in the application. If I want to, I can delete the other one, Spark. Plugins, Tiles, Spark. And it's gone. We only have the clock. And what happens if I copy back again? Let's remove this because that was a typo. Now I'm going to copy all the plugins again from the prepared directory into my real staging directory. I got those two plugins back. Now, of course, I'm doing this externally to my application, but if I really wanted to have more a user-friendlier experience, then there will be a menu that will say find the plugin from some sort of plugin portal, download it and place it in the specific directory, and off you go. The plugin will be automatically available to you. And there is another option in the menu to say plugin manager, uninstall plugin, that knows where the jar for this plugin is and delete it from the file system or move it to somewhere else so that Layrry will detect that and remove the plugin. Now that you have seen how the application works, what it does, let me show you the code that actually makes this work. We start with this class. Now we should be in IntelliJ, and it should be in just a moment appearing on the screen. A class that implements the plugin lifecycle listener from Layrry. This class is called Tile Plugin just because I want to. And what we do is provide an implementation of that interface. So we have to figure out what to do when a plugin is added, line 32, and when a plugin is removed in line 52. From this point onward, the code that you invoke here is your code, is your application code. What this little class is doing is loading services that are type tile plugin, again, application specific. And then once it collects all of them, just to be sure, it registers them with a class called plugin registry. This is, again, application specific. And when a plugin is removed, it will invoke again on the plugin registry another method that unregisters all those plugins that are belonging to a specific module layer. So, what is a tile plugin? This particular class here, it's an interface that says, well, I had some sort of identifier, you can have additional code, and it has two methods, what to do when something is registered, and what to do when the plugin is unregistered. And we're using completion stage, which is an interface, a super interface for completable feature, because of JavaFX and nothing more. Everything that is UI, this is the golden rule of writing desktop application, whether it's Swing or JavaFX. Everything that is UI must happen inside a specific thread. In Swing is the event dispatch thread. In JavaFX is the application thread. Everything that is not UI specific should happen in a completely different thread, but it cannot be and it should not be the UI thread. For this reason, given that plugins are being loaded in which we don't know which thread it is, but they contain UI logic because we saw there is some UI elements, then we need to run code in the UI thread and then come back. So that's the reason why we're using completion stage, which kind of works like a promise. The other class that we have to look at is a plugin registry. When we register a plugin, let's see what happens. What this thing does is check this. Do I have the plugin for that particular layer? No, I don't have any plugins. All right. For each one of those plugins, we check if we have a context. This, again, is application specific. What is a context? It's something that contains a reference to the window. If the context is null, that means my application is just being started. JavaFX has not been initialized yet, so I cannot instantiate the plugin yet. I cannot attach it to something that is not there yet. So I'm going to register into some list as something like, oh, this plugin I will handle later. That's fine. But if the context is available, then I just register. The other way around, the symmetric version of the API is that if I have a plugin for that particular layer, then I'm going to iterate over all the plugins, unregister, untrack them, remove from the list and from the map, and boom, you're done. There's nothing else. So the trick will be how to handle plugin registration. We move into that method, and this is where we make use of that completion stage. It's going to register, which returns the completion stage. If it's successful, that means the plugin was successfully started and attached to the UI. So I'm going to keep track of this. If I don't do this, then if I receive a remove event, I might not be able to pinpoint the exact plugin, and I may have a memory leak. If the registration had any errors whatsoever, which anything could happen, then it's going to throw an exception. Well, actually, it's going to print out an exception. We will use that exceptional method from the stage. If we want to look at a specific implementation of that, this is what it does. Creates a promise, executes code inside the UI thread. This is how it initializes and attaches to the UI, and it does everything that it does. If it's correct, it completes. If it's in error, then it will fail. If there's any other kind of error, this is the error that happens when you want to initialize without JavaFX being fully initialized. Then we just attach it here, and we're done. Right. So this is basically it. Everything else that you do is, the rest is application specific. If we were to look at how the clock is implemented, this is one class. Here we go. It's just UI code. And it knows, based on that base class, how to attach itself to the specific context, which is the window that we saw before. And from then on, if you want to grow this up into something more elaborate, like something that looks like an IDE or some other kind of application, then the sky is the limit. You may provide a different kind of context application, and that's it. But maybe you're thinking, well, Andres, this is nice, but I'm not a desktop developer. I don't care much about JavaFX. I do care about serverless, though. I do care about other frameworks and libraries. Well, there is an option for you. I believe I have, do I have this, the Layrry links? There it is, Layrry links example. And it's going to open in a different window. This is a BordeauxJUG application. And it also contains plugins. And I believe here we have a Layrry listener. Is the road contributor right here. This is what your plugins, your Vertex plugins need to implement, if I'm not mistaken. There are different plugins. In this case, they're called contributors. This is the standard Vertex vertical. I'm going to make the font a little bit bigger. And what this application does is listen to plugins and attach new routes to Vertex. So each one of these plugins will be able to give you additional routes when running the application, and you can add and remove routes just by adding or removing jar files from the plugin directory. Okay. Let's so that's the code. Let's, where is the share? Oh, yeah, I know what I need to do now. Go back to, well, let's kill the application. There we go. And let's go back to playing the slides. Given a little bit of delay, we should be about now. So, what's coming up in the future? You may be having some questions. It's nice that we can use the Ray launcher.
Yes, one question.
Yes.
Do you want? Do you see a chat?
And yes, if I quit the slides. There are dependencies as it follows. Modules from upper layers can depend on modules from lower layers, but lower layers can depend only on services exposed by upper layers. So it's true. Upper depend on down, but lower layers can reach out to services that may come from different layers. They could be up or they could be down. And this is a really good question, because if I go back to the modular tiles and I showed you the TOML file, which is right here. No, that's not it. It's right there. We can see there is a JavaFX layer that appears to be at the bottom because core depends on JavaFX. But notice that the plugins layer appears to be disconnected. Neither JavaFX nor core depend on plugins. The plugins depends on core, yet the lifecycle listener that we have here, the plugin listener, it's found in the core layer, but the services are being exposed by a layer that is upward, is the plugins layer. So if you use, how can we make this happen? When we look into the module descriptor of one of these plugins, it provides a service, a tile plugin, using the specific clock tile plugin. So that's one thing. And the consumer, the core, simply says, I'm going to use instances of tile plugin from wherever they come. And that's how you make this happen. And the other thing that you also need to do is, because this particular module is providing a plugin lifecycle listener from Layrry, it must define that it exposes the implementation of that interface. All right. That was a really good question.
Okay, and another question?
Yeah.
Yeah, a bit.
Well, the question may be somewhere else. I don't see it yet in the chat.
I try to invite.
Oh, I see where it is now. It's in the question and answers.
Sorry.
No, that's fine. Is there a risk to have a Novembre jar if all modules come with their own version of a dependency?
Yeah, so I understand there is no more dependency resolution. So all module can come with its own dependency. So in the end, do we have all the versions of the dependencies in the final jar?
So what you're saying is that you have a modular application, all modules all over the place, and you compile everything in one single jar. What's going to happen with the module information?
Yeah,
that's a bit of a problem. Both the Gradle shadow plugin and the Maven Shade plugin, they skip the module info class because there is no way to merge it easily. It's something that you have to do by hand. But if there were a tool, there was some sort of tool support that will allow you to merge all those things into one single coherent module descriptor, then your UberJUG will still be modular. It's just that one last step, in order to merge everything, does not happen yet automatically. It could be done using ASM, written bytecode, and do it on the fly. But as far as I can tell, no one has done it yet and packaged it as a Maven or Gradle plugin. But it's an interesting problem to have.
Yeah. And I have another question.
Yep.
Is it compatible with the GraalVM?
Yeah, kind of. So Graal does not support running modules yet. So Graal VM is the Graal dependencies are not modular yet. That's an open ticket that has been being worked on this year, and we're hoping that, well, I'm an Oracle employee, but anything that I say is like just take it with a little bit of grain of salt. I have no clue on dates for releases. We just had one release, Graal 20.3. Was it yesterday? Was it just today? And it does not yet have this feature, but I'm hoping that the next feature or the next two features, whenever they're ready, will have these capabilities. That's something that we're looking at. Being able to launch or create a Layrry-based application as a native image, also being able to launch a Layrry application as a JLink image, which one of the challenges here is that a JLink image behaves a little bit as a shaded jar or an UberJUG.
Okay, thank you.
Thank you.
Thank you.
All right. So
it's okay.
Thank you. So the future, what's going to happen? Well, everything is fine if you run things locally. So you have all your jars in a Maven repository that may be local or maybe a remote. You may have external configuration, but it has to be local. So what if we were to have external configuration also remote? What if we were to host the YAML file or the TOML file, whatever external files, in a remote location, and have Layrry locally point out to that resource, download it, and then pull all dependencies where needed and launch your application? Well, that, my friends, is already a pull request that exists in the Layrry organization. And we're still in the initial works on figuring out how this thing can work, but it's certainly something that we're looking forward to. Another thing that we want to do is that allows you to create applications using Layrry and launch it in many different ways. So you may use the shaded jar, the Layrry launcher, or you may use JBank, but we also want to just supply a Layrry binary, like a regular Java application that you can run, a command line application. And so for that, we're going to make available ready-made binary distributions with different distribution channels, such as publishing to the GitHub releases or making it available to Homebrew. Or you may be familiar with SDKman, which allows you to install a set of Java-related tools. So that's definitely another option. Or maybe a Snap in Ubuntu, or maybe a Scoop or Chocolatey for Windows. There are a few other avenues, other distribution channels that we can have a look at. I'm going to turn quickly into the source code. So I'm going to wait for this window to sync. And because besides running remote, there is another option. I believe, let me check in which branch I am. I am master branch. So let me change into, what is it called? Remote layers. Check out. Let's go into that one. And one of the examples here on the integration test that we have.
Sorry, for screen, is the IDE or terminal screen?
It's in the IDE.
Ah, yes, okay.
Right. So we have a different set of integration test cases, and we have one that performs a remote test case. Now, this particular test case host the layers config file using Jetty that is found here. Just simple Jetty configuration and exposes the YAML file or the TOML file. Now, if I were to run the test case here, then we will see that that Jetty gets started, and then Layrry downloads either this resource or this other resource, and it works. And that's fine. Again, those artifacts are coming from a Maven repository. Here's another thing that can happen. What if instead of having a remote configuration file, a remote artifacts, you want to have everything local. You want to package all the artifacts in some sort of layout so that when you bootstrap the application, all the jars are locally available and nothing else. This way, you escape interacting with Maven or any other tool. So that is local artifact support, local repositories. Yeah?
Excuse me, you show module. I don't show the correct window. The problem to refresh screen.
Okay.
No delay in refresh. Yes.
Now you can see it?
Yes. Okay.
Oh, perfect. Excellent. Here is another version of the integration test case. This one uses the Layrry API. And this is the same version using the Layrry API, but the difference now are these 3 lines of code. With these 3 lines, it's saying, I'm going to disable querying any remote repository. One thing. The second thing it says, I'm going to enable one local repository that has a layout of type flat, and the directory where all the jars can be found is this one. So right now it's empty because I haven't built anything. If I quickly switch to the terminal, run it, and then come back, I know that you won't be able to see it quickly. And but let's make sure. And in this case, I do want to make a clean install, just to be sure that there's nothing lingering there. There will be a quick test here. And the important bit will be to see the generated files. So if everything is done correctly, the test should be green, and integration tests are working perfectly. Copying some jar files, I will show you where these jars are right now. And the build continues. I think we're almost done. There we go. Build successful. So we should be back into the IDE. And the target directory, there is a folder called repositories. And here, I don't know if I can zoom in here, but all these jars, should I need to refresh?
No, the screen is blocked. I don't directory target.
How about now? Is it visible?
Okay, yes.
Okay, perfect. All right. Thank you. So here, all these jars that we see here were placed by the Maven build into that specific directory. Target repository is flat with matches we're respecting here in our test case. So all these jars here match the names that we find here in our configuration. If I were to remove one of these jars, then I will certainly break the test case. If I were to comment out these lines of code without any remote resolution, my test case would also fail. So with this, I can test out that we have both support for remote layers, still forthcoming, and support for local repositories that are completely disconnected from any Maven repository. There are a few other ideas that we're testing out. And so we are more than happy if you were to just give it a try and give us feedback if you are so inclined. I have a few resources for you. You might remember that I mentioned that Gunnar likes to blog, and his personal blog is morling.dev. There are 3 blog posts that he posted. The first one is where he introduces Layrry. The second one is where he describes plugin architectures in the context of the app application that we saw before with the grid, the conflicted modules, and the Vertex application. And the third one is an investigation that he did for memory leakages. Because as it happens, the JavaFX application that I demoed today had a memory leak. One of those UI components that we saw starts a thread to keep track of all the random data and do the refresh of all the information. When I wrote the application, I was not aware of that particular thread. And even though the plugin, the application received the plugin remove events, there was still a class lingering around because the thread was active. So we had that memory leak. How did Gunnar find this problem? Another thing that Layrry does is that it triggers Java Flight Recorder, JFR events, whenever a plugin is added or a plugin is removed. So he plugged in the data coming from JFR into Java Mission Control and another tool, and he was able to pinpoint and find exactly where the problem was, and we fixed the code. And that investigation is described on the 3rd resource. So if you want to know more about detecting memory leaks plugins with JFR and Mission Control, this is a good thing. And if you want to know more how we do it with Layrry, then again, this is a really nice resource. The next link is the link to the project, the Layrry project in the Moditech organization. And the last one is where you find some examples. So the Vertex example, the Gritter example, and the Modular Tiles, which is the JavaFX application, are all available in that repository. Some of them are built with Maven, and the readmes contain every single instruction that you need in order to run and test the applications. If you encounter any problem with those instructions or something else, then let me tell you about contributing to open source. Because everything that we saw today, and probably many things that you use in your daily work, are based on open source. And the easiest way to contribute to open source, if you haven't done so before, is file a ticket. That's it. There's nothing more. If you have the time and you want to send some code and a patch, a test case, sure, why not? Let's do that. Become a contributor if you want to, even become a committer to a project. We don't know where things will go. But at the very least, if you find a problem, if you find that maybe there's a missing feature or something that is not working correctly, the documentation is not, is ambiguous, it has troubles, there's typos, just file a ticket, and that's it. And I believe that's what I have for now. And if there are any questions, I will be very, very happy to take them.
Okay, thank you. Do you have a question?
Just want to find out, how do I close the sharing? Oh, I see now. Yes.